The Parker Solar Probe created history by becoming the first spacecraft to touch the Sun. It passed through the Sun's upper atmosphere, where temperatures can soar up to 1,000,000 degrees Celsius. This is the hottest region of the solar atmosphere, but why didn't the Parker Solar Probe melt when it touched the Sun? No metal can withstand such high temperatures, so how did it manage to survive after plunging into the solar atmosphere? And how on earth is the Parker Solar Probe still functioning efficiently after going through such an extreme environment?
The story behind the Parker Solar Probe is truly something unbelievable. What exactly is a Parker Solar Probe? The Parker Solar Probe is a NASA spacecraft designed to study the outer corona of the Sun. Temperatures in the solar corona condition soar up to 1,000,000 degrees Celsius. It was launched in 2018 and is on a mission to collect data about the Sun's atmosphere, magnetic fields, and solar winds, providing valuable insights into solar space weather. The solar corona is a mysterious region of the Sun. The laws of thermodynamics tell us that heat cannot flow from a cold body to hotter one. So why is the Sun's surface at around 5,800 degrees Celsius and the solar corona at over 1,000,000 degrees Celsius? Let me explain it as easy as. Although the corona has a high temperature, its particle density is very low. That's where the concept of heat versus temperature becomes important. Temperature measures how fast particles are moving. But on the other hand, heat represents the total energy these particles can transfer. So even if particles are vibrating tremendously and have a high temperature, if there are very few of them, they won't transfer enough energy. As a result, they would correspond to lower heating. Let me give you a quick example so you can better understand it. It's like putting your hands in a heated oven and a bowl of boiling water. Your hands can stay for a longer period in an oven without getting much heat because the particle density is lower than in the boiling water bowl. For the Parker Solar Probe, this concept of heat versus temperature is the backbone behind keeping things safe from melting. Since the corona's density is lesser than the visible surface of the Sun, the spacecraft encounters fewer hotter particles. As a result, it doesn't heat as much as it would in the case of the visible surface. Eventually, the sun-facing heat shield only gets heated to 1,400 degrees Celsius, even while passing through an atmosphere of several million degrees. So how did the spacecraft tackle? The answer lies in its thermal protection system, which comprises a shield made of carbon composite foam sandwiched between two carbon plates measuring 2.4 meters in diameter. Despite being thin, it can withstand temperatures up to 1,600 degrees Celsius and allows the spacecraft to maintain a temperature of 30 degrees Celsius. The Parker Solar Probe is not only studying the Sun, but it is also powered by it. As the solar panels get closer to the Sun, they might overheat. To keep things cool, the spacecraft circulates a single gallon of water through its solar arrays. The water absorbs heat as it passes behind the arrays and then radiates that heat into space as it flows into Parker's radiator. And finally, the heat shield edges are accompanied by 7 smart sensors. If any of these detect direct sunlight, they alert the central computer, which directs the spacecraft to correct its position. This way, all the components are safely protected behind the heat shield. If everything goes as planned, the probe will send data from within about 6 million kilometers of the Sun's surface by the end of the mission. Thank you for joining me on this fascinating journey into the heart of our solar system with the Parker Solar Probe. If you enjoyed learning about this incredible spacecraft and its mission to unlock the secrets of the Sun, don't forget to hit the like button and subscribe for more space exploration content. Share your thoughts and questions in the comments below. Stay curious, stay inspired. And until next time, keep looking up at the wonders of our This Is Our Endless Universe, signing off.